Hey, hi everyone. So in this video, we'll see how to build like a deep research project similar to what Perplexity does. And we'll build this using LangGraph. So let's just see what Perplexity does. I've tried to get inspiration from this and build the project considering this as the standard. So I asked this question like what are the recent advances in quantum computing, and it goes through these steps that are there. After going through these steps, it generates this report about all the advances that are made in quantum computing. It's talking about some quantum error correction and all. I don't understand these things. I should have asked like a easier topic which I understand. But the whole point is like these steps that it goes through. I've seen like the first step is it generates these search queries and gets the result from the internet related to the query that we ask. The second step is it again refines the search queries, gets the search results again, and then it sort of starts wrapping things up. It's kind of like summarizing each and every source that it went through at this point. After it's done summarizing, it sort of writes the report. This is the report that we get, and you can also see the sources here that it went through in this entire process. So that's how it's researching the topic and trying to come up with the report. So we'll also build something similar. In fact, even in terms of like the UI and the methodology, I've tried to keep it same as Perplexity. So let's try the exact same query in our project and see how it works. So what are the recent advances in quantum computing? It starts running. Like the steps will be shown here, just like Perplexity. It's not so cosmetic like Perplexity, but yeah, let's just wait for a while. So looking into initial set of search results. So even our project comes up with these search queries basically, and then these are the corresponding search pages or results that it's going through and reading now. And then it does like a refined search query based on findings. So after going through all of this, it again starts searching for newer things, and then we get results for those new queries. So you see like here the queries were pretty generic, but here the queries are pretty specific about recent quantum computer error correction developments and so on. So it's like it's gone through this, it got some ideas, and then now it's searching about deeper things to understand specific topics. And now it's like I just added this one section where it summarizes every single result that it read here in this section, similar to what Perplexity does. If you go to the final report tab, this is the final report that we get. Again, similar to Perplexity. It mentions these things in like certain sections and all. It decides all the sections by itself and gives us this report. I've asked it to keep the reports short. That's why it's not going so elaborate. But yeah, it can depend on how you write the prompts and all. We'll see everything, how to do something like this. And then of course we have like list of sources that it went through. So let's jump into the code. Let's see how we can do this using LangGraph. All right, we have this project open here, and there are basically 4 files that I've distributed the code in. I have not refactored the code too much so that most of the code remains in one file and it's easier to understand. Main.py file is basically the Streamlit file and the UI design things. It just integrates with the code that is present in the backend, which is LangGraph workflow. At a very high level, this is just the Streamlit and UI code. LangGraph workflow is where all the actual graph and actual implementation of the graph lies. Prompts is the place where all the prompts are there. LangGraph uses all these prompts from here, and utils are like just 2 functions that we have: call LLM and get search results. So this is something that I've thought I'll keep it separate. Again, LangGraph workflow uses these 2 functions in the utils. So LangGraph workflow is kind of like the most important or the actual main file for us. I was thinking I'll go through the code, but before going through the code, there is somewhere in the code where I compile the graph, the LangGraph graph, and I save it in the image at the PNG format. So let me so I've already ran this code, right? So let me open this PNG and show you the graph even before going through the code, so that you have an idea of what workflow we are dealing with. So yeah, this is a very simple workflow that we have. When we start with this query planner agent, and this comes up with the initial set of queries and search results, it goes through that search results. And once it's done, we send it to this other agent called should refine query. And then after going through the search results, it tries to come up with new search result if it's curious about newer topics. Otherwise, it goes through the final report generator, and it will keep doing the refinement. It will keep reading articles, keep searching more till it gets enough content about topics. That is why this loop edge is present. And then once it's done refining all the queries and gathering all the resources, it goes through the final report generator, which generates the final report, and then we end the workflow. So that's the simple workflow that we are following. Let's quickly go through the code. So there are like these three constants that we have. Max query generation. So how many max queries you want to generate in a single go. I've set it to 3. You can also see in this steps, like only 3 queries were generated at each step. So that's because of this constant. And then max results to fetch. So for each of these queries, we'll fetch top first result, only one result. There are some complications related to this further down in the code. You'll see about it. But it's not like always one. So even here you can see like there were 4 results that were fetched, and here is like even more. So it's not exactly one, but yeah, we'll see how this works. And then there are like max query refinements. So this loop can go on forever, but we don't want that. We want to limit it using some number. Even if the agent says, oh, I want to read more topics, it can keep going on and on. So we limit it using this constant that we have. So we have set it to only 2. That's why it may be refined like the query only once. That means it made query like 2 times. That's where this constant comes in. Yeah, so that's about the constants part. Let's quickly see what state are we going to use in LangGraph. So this is our state definition that we have for our LangGraph agent workflow. So we have a user query here. So before going through this state, I've discussed like basics of LangGraph in previous videos. So if you don't understand basics, it will be tough for you to understand this project. I've discussed like parallel agents and conditional branching as well. There are a few more concepts that we learn about LangGraph in this project, but you should definitely go and check out previous videos about LangGraph if you're confused in this. So in our project, for the states, we have a user query. This is the actual user query that the user puts. So in our case, it's like this one. What are the recent advances in quantum computing? And then we have search queries. So you see like operator add. That means we'll keep adding all the queries that we generate throughout the project in this attribute. Search results are again like list of search results that we get. We'll keep accumulating them here. Individual page summaries is something like this thing that we saw. This is the list of individual page summary. So every single page or result that we have, it summarizes that result here. And then we have report markdown. This is the final report that we generated in markdown, just a string. And then we have query generation count. This is what will be used along with this max query refinements to see how many times have we generated queries and refining queries. So we'll always keep incrementing this count, and in the state we'll check if this count exceeds the max query refinements, then we'll break the loop sort of. So that's why this count is used. So let's go through the nodes, but before going through node logic, let me at a broad level show you the graph as well. So these 3 are the node functions, as you might have guessed. Even like previous videos, we know how LangGraph works, like each node has its own functionality. But this is our graph, how we define. We have given the state here. There are 3 nodes that we'll add. The query planner, should refine query, and final report generator. This is what we saw in the graph diagram as well. We add an edge from start to query planner, and then query planner will go to should refine query. And then we have an edge from final report generator to end. We haven't defined any edge from should refine query to final report and the looping thing as well. That's because we are using this thing called command in LangGraph. So basically this agent would want to update the state as well and go to a different node if the condition allows. We want to do both of these things together in this node. That's why we are using command here. And whenever we are using command, we don't have to define the edge here. But the way LangGraph will work is we define the return type here and we give command literal. So it can either go to should refine query or it can go to final report generator. That's how this works. So that's why we need to add like the return type in this node function. This should refine query will again go back to should refine query itself. That means it's a loop, or it will go to the final report generator. That's what this means. And then we compile the graph and we are saving the image of the graph. This is like a one-time thing. You can also comment out this code. We'll go through each and every node functionality, but very quickly, like if you just want to run this as a standalone script through LangGraph itself and not use Streamlit, you can do it. So you can just build this graph using this function, and then you can sort of stream the output. So this is again a new concept in LangGraph that we haven't looked at before. Command was the other concept. We haven't looked at command, but I hope command would be like more or less clear. We'll discuss more about command. But this is how you can stream the response as well from LangGraph. It's kind of like we can do graph.invoke to get the final state, how we have been doing till now with respect to the previous videos. But in this case, we call dot stream rather than dot invoke with our query. So this is the initial state that we are setting, and then we can sort of print the chunks as they come in, and these chunks will be the differences in the state. So whenever there is a state change by any agent, this will be printed. You can actually run this code and see for yourself. In fact, we may also run it. Let me explain the code first, and then maybe we'll run this streaming part and see how it works. So let's go through the node one by one. Let's look at the query planner node. So first thing it will do is it will take in the state input. It will read the user query, and it will also take in this query generation count. So it will default to 0 if it's not set. So we have these two things getting read from the state. It will see the current date that we have. This is useful, I've seen in generating queries. So if you see here, the query contain like 2025 and all. Sometimes it's useful if LLM decides to put dates in the query. It's nice to keep LLMs aware of the current date that we are in. So this current date is passed to this prompt. So we have a prompt now, this generate search queries prompt. And to this prompt, we are passing the actual user query, current date, and max query generations. We can look at this prompt now, the very first prompt that we have. So this will just given user query, generate list of search queries. So whatever searches we want to make, this is a simple prompt that we have. We have given some guidelines and all. I'm not going to waste time reading the prompt, but I have given like a summarized version of this prompt in the comment so that you know at a broad level what the prompt does. So from the search response, we are getting all the search queries that we want to make, and we are just converting it to the list. Sometimes I've seen it gives quotes around the search queries, so we are just stripping the quotes. And then sometimes I've seen it gives like bullet points, the search queries in bullet points, so it adds a hyphen in front of every single query. So we are stripping that as well. There's just some guardrail stuff for LLMs doing random things. So once we get the search queries, we'll limit it to max query generation. So even though we are asking LLM to generate only max query generations queries, basically 3 queries, it can decide to generate more queries because it's LLM. We can still set a hard limit. So we'll only take like 3 queries even if LLM decides to generate more. And then we'll get the search results. So this get search results, we'll send in all the search query that we have one by one. We'll send this max search results. And here we are sending the previous search results as well. So the way this get search result function works, it will take the query that we want to search. It will take this max result, and then it will also take previous search results. So we are using this DuckDuckGo Python SDK for this. It kind of worked for free for me without any limiting issues. So you can try with DuckDuckGo itself. The reason why we need like previous search results is if we have like 3 queries and each of those 3 queries resulted in exact same page, we want some new pages, right? Because we have already read that page. So that's why we get this visited links. So this from this previous results, we get the already visited links, and we remove them from the new search results that we have. We filter them. Since we are sending this max results to DuckDuckGo API, it can so happen that all the results get filtered because they have already been read previously. That's why we add max search results with the length of the previous search results, so that in any case, if every single page gets filtered out, we still have this new max search results remaining in our list, which we can visit. But this can create another issue. If none of the search results were duplicates and all of them remained, this will lead to the other extreme. So that's why we again limit the search results. I have kept just some room to wiggle, so I've just done like +1, so that we go like a little bit more than max results. But you can remove this if you want like a very hard strict rule saying like it should only be max results. You can go through the code and understand. It's not very complicated. And then we visit every single page, get the text content out of it, and save it in the retrieve results itself. And then we send all the search results that we have. So it contains like links, title, the text content of the page, and maybe a short summary of that. Oh, here I've done like a small thing. So every text content that we read for every single page, I have limited it to 2000 characters. So in case like if a page decides to be like just too long, we still limit it. This can be increased. I've just set it to 2000, but you can go well beyond like 5000, even 10,000, because this is characters, not tokens. So this is how get search result works. Once we get the search results, we'll do this for every single query, and for every single query we keep sending the consolidated search results so that we don't repeat. So when we are searching for the next query, we don't repeat whatever search results we went through for the previous queries. And then we return this state. So we'll update search queries. Remember, this will be appended, not updated. Search results will again be appended, and then query generation count, we just increase it by 1. So that's the state update that we'll do for the very first agent, the query planner. In the should refine query, we again read the original user's query. We read all the search queries that have been made till now, all the search results which we have gotten till now, and of course the query generation count that we have. So the current query generation count will come in this. We again get the current date. Here we first make a call saying like if count is more, then just return. So the way this command works is, so now we are not returning a dictionary to update the state, but we are returning this command. So in this command we'll have update. This is the original dictionary that we have for whatever state we want to update, and go to is the next node that we want to go to after updating the state. So in the command we just get to do both of these things simultaneously together. That is how command works. So if we are well within the count, we sort of make this string format of search results to give it to the prompt. So we add like this title, content, all the text content, and we join it using this new line equal to. So every single page is appended in a string format, and this is sent to the prompt. So this is another prompt now, refine search queries prompt, where we are sending in the original user query, current date, all the search queries that we have made till now, and the search results that we have, and the max query generations. And we'll ask it to tell like, hey, these are the queries that we made. Do you want to make more search queries? What are they based on these findings that you have, based on these pages that you have? So it will go through all the pages, all the search results, and try to see like if these queries were made and these results we got, what all new queries we can make. Let's just see the prompt as well very quickly. So this is the second prompt in prompts.py. Given user query, search results, generate refined search queries. That's what this prompt does. You can also pause and have a look. I anyways have the link of the code below, so you can also go through the code and see this prompt properly rather than pausing the video and all. Basically this will give you list of search queries, and then we do the same processing here, remove quotes and strip hyphens and all. There's one additional thing that we do here. Actually I've removed it now, but in the prompt I was asking it to return none if it does not want any refinement in the search query. So if there are refinements needed, it will give me like one search query per line as a response, or it will just say none. I saw what it was doing is it was always giving none, and that's why I removed that line from the prompt, and now it always gives some of the other refinement that is needed. But you can add it back in the prompt and this will still work as is. So this prompt can decide on its own. But since anyway we have this count thing, like even if you compulsorily refine queries, it will go till this max query refinements. So yeah, once we get this refined search queries, we'll again limit it to max query generation in case LLM wants to generate more queries, and then we'll get search results for those queries. Here we are having a condition saying hey, if refined search queries were present, then we'll update the state and go to should refine query again. Else, if this refined query was not present, that means none was filtered out, and this list we got empty. So this list is empty. That means no refinement was needed, and we can go to the final report generation. This is what this means. Otherwise, it will loop back again to the same should refine query. So this is what it does, like goes back, and then these are the states that it decides to update. It updates the refined queries, the results, and the count as well. I think one small function that I forgot discussing is this call LLM. It's again a util function. It's a very small OpenAI call that we make. Model I've defaulted it to 4o. Can change the model however you want. This system prompt. So every prompt I like sending it through system prompt. It just returns the result. That's a very simple function that it does. We have seen this should refine query now, and let's just see what happens in final report generator node. So it's a simple node, takes in state, takes in the queries, the search results, and it again generates a string of this search result so that we can send it through the prompt. And then we call this one final prompt with the original user query and the search results, asking it to give us the final report. And what I did is in this prompt, if you see, I am asking it to generate search result wise summary as well. So I've asked it to generate like summary of every single page and then the report. So what it will do is, I'll show you an example. It will use these summary tags to generate a summary of every single result that we have. And then within this final markdown report tag, it will generate the actual report, the markdown report that we want. And we have given like inputs here. So that's how this prompt works. And here we'll extract out the summaries. So we'll get like summary for every single result that we have. This is used to just display on the UI, nothing else. And then we'll extract out the final report as well using these tags. It's just a simple regex. And we are updating the state here. So individual page summaries is the list of strings that we have, and report markdown is just the string that we have. And once this is done, the final report is saved in report markdown, and we have all the states updated. On the Streamlit side, very quickly, we initialize these session states that we want. So this is the streaming part that we do, fetch results streaming. But this is the UI setup. So the title and the query, the input query that we do. We have 3 tabs here that you have seen: steps taken, final report, and fetch sources. So we start using this function fetch results streaming, and then based on whatever gets streamed, so the way it gets streamed is every single node, whenever it visits a node and whenever that node produces an output, the change in state, it returns that. That's how LangGraph streams. And if you see this fetch streaming function, we are just building this graph and we start streaming for chunks using the query that was entered through the UI. And then we are updating some session states basically, and these session states are displayed as they are streamed through LangGraph. And then these are just conditions. I don't want to go much into this. You can maybe probably just read through and see, but this is just how to display things beautifully on the screen. That's what this code is. It's no real like logic or anything. The real logic is all in LangGraph workflow. I'll very quickly show you the example of this. Let me just open the terminal. Great, so we have Conda environment enabled. We'll call LangGraph workflow.py. Good. So since it should start printing the chunk one by one, and we have used a query here like have we reached AGI with Manus AI. It's taking some time, I guess. It's searching results. Okay. So this is the first chunk that it printed. So this is the query planner node, and this is the state corresponding to that node. So all the things that you see, it has these search queries. So it generated like 3 queries here. 3 queries is what we have set, and then these are the search results that it has. There is title, there is href link for that result, there is body for this, and then there is text content, the complete content that we have. So this is about the query planner node. It didn't generate for should refine query yet. I should have added like a separator here, But yeah, here you can see like query generation count is 1. So this is the first iteration of queries and reading the sources. I should probably highlight this if we get lost. Okay, so after some time it generated the should refine query. So should refine query is here, and then these are the refined 3 queries that it wanted to make and the corresponding search results. And then you can see the query count is 2, and now it sends another chunk saying should refine query is none. This should basically be like the next time should refine query runs, but we return it because the max count is reached, and then it goes to the final report generator. That is why we get this chunk, and then we get final chunk from final report generator, which contains like the final report. If you see individual page summaries, and then it might be difficult for me. Okay, I found report markdown, and it contains the report markdown. So basically every single node, so these are the nodes, and then whatever state change that these nodes are making is coming as the value. So this is the dictionary of all the state change items that it returned, and that is getting streamed. So whenever we invoke a graph, we'll get the final state with all the values, but we can also stream it like this, so that even if one node is done, we kind of keep getting the output, and we can keep displaying it in the UI, something like what Perplexity does. So we have gotten this final report here, and that's how the program ends. So yeah, that's it. Like hopefully you enjoyed. There are a lot of refinements that you can do in this project. For instance, the should refine part, I've removed the none, so you can add the none back, and then you can make it more intelligent as to go deeper and all. And always remember, like, this is the state that I designed, this is the graph that I designed. In your mind, things can be completely different. You can have like different state altogether depending on how you want to do things. You might get inspiration from Perplexity and decide to do something else, which is completely fine. This is not like if I have designed this graph, this is the only correct way to do it. There can be like 100 different ways, 1,000 different ways, and even the states. For all we know is we could have done like every single thing in one node. That is one extreme. Or else people add like usually like a planning node here, which just plans. Our query planner right now reads the articles as well. It scrapes through the articles and all, but you can only generate the plan and so on in a planning node. You can break down prompts even further. This individual page summaries and report markdown are added together in the final report generator node. So this final report generator node, the way the prompt we have written, it gives individual page summaries and the final report together. So that also can be broken down into 2 different nodes. You can have like generate summaries for each page and then generate the final report as 2 separate nodes. Depends completely on you how you want to do it, what suits you the best. Hope you enjoyed, hope you learned something. I hope to see you in some next video. Thanks guys, bye.